Good day everyone. By the way, I am Fabi Ibitur from BSc 2B and I'll be presenting or I will be reporting about the Module 2 Lesson 2 about how computers interpret data. So this presentation will cover how computers process data from human input and display it as output. We'll explore the role of binary code, ASCII, and the different stages of data processing. So, by the end of this lesson, you will be able to learn how computers use binary code like ones and zeros to process data. Next is understand how ASCII converts letters and numbers into binary. And the last one is know the steps of data processing. Those input, processing, storage, and output. Computers interpret data by converting human input like letters and numbers into binary code, a language made up of zeros and ones. This process is made possible by the American Standard Code for Information Interchange, or what we call ASCII, which assign unique binary codes to each character. These systems allows computers to process and display information in a way humans can understand. So, computers work differently from humans when it comes to understanding data. While humans use letters, numbers, and symbols, computers rely on binary code, which consists of only two states, the on, or which are the ones, and off, which are the zeros. And to bridge the gap between human readable data and machine readable data, computers use ASCII. Because ASCII assigns a binary value to every character on the keyboard, such as letters, numbers, and symbols. For example, the letter A represented as 01000001 in binary, which with the different types of number systems, it is important to understand how computers interpret the letters on the keyboard through a series of zeros and ones. This is normally done through number system conversion. Depending on the standard used, computer system convert characters from the keyboard and later display them on the monitor. So how computers interpret data? The process of interpreting data can be broken down into four main steps: the input, processing, storage, and output. Each stage plays an important role in ensuring that human input is understood and displayed correctly by the computer. So we have number one, the input. It is when a key is pressed on the keyboard. Pressure pads under the key sends a signal to the computer's CPU, or Central Processing Unit. For example, pressing the letter A sends a signal to the CPU. And the second stage is processing. It is when the CPU uses ASCII to convert the signal from the keyboard into binary code, which is made up of zeros and ones. For example, the letter A becomes 01000001 in binary. So number 3 is storage. It is the CPU determines what character has been typed and sends the information to the computer monitor, again in zeros and ones. For example, the binary code 01000001 for A is stored briefly. So lastly, the output. The CPU sends the binary code to the monitor where it is shown as the letter A. For example, the monitor shows letter A on the screen. In conclusions, computers use binary code to process data, converting human input into a machine-readable language. ASCII, or American Standard Code for Information Interchange, is important in translating letters and numbers into binary. The steps of input, processing, storage, and output function together to ensure data is accurately handled and displayed.